Okay, so there is quite a bit we're covering today. Again, going to look a little bit familiar to what you have seen before. But what we're going to do is look at parabolas today. So everything we are dealing with is going to be a parabola or a quadratic function. We're going to look at the two different ways that quadratic function can be handed to us, as far as like our general form or our standard form, and how we graph it from that, and how they're related to each other. So you'll see, does it have maxes and mins, how to find those maxes and mins, how to graph our parabolas. So we're going to jump into the graphing part of it. Your parabola function can be given to you in either, we've heard these words now several times, standard form or general form. Standard form is the nice one because it is easy to see where the vertex is located. So we had two quadratics at the beginning of our warm-up. One of them was in general form and one of them was in standard form. And like I said, the standard form is really nice to show you where exactly that vertex is. The tricky part on this, it's not like a circle like we saw in the other lesson. In your vertex, you have to remember that H is going to be the opposite sign, but K will be what we see. Okay, so whatever sign K is the sign on K. Whatever sign H is will be opposite in your vertex. So again, inside things we think opposite. The number in front of our parabola will tell us a little bit about our picture. If this number is positive, greater than 0, our parabola is going to be a normal open up parabola. But if this number were to be less than 0, something negative, our parabola is going to open down. So it tells us kind of what shape to be expecting, what the dots to be expecting in there. And then one other really nice thing about parabolas is this thing right here called your axis of symmetry. Notice this dotted line right here. That's not really part of the graph itself. But what it's true is it will always run exactly halfway right in the middle of our picture. It'll be identical on the right and left of that axis of symmetry. And we can use that to help us graph, because if I get a dot on this side, that identical dot will be on the other side of that line, which means half as much work for us finding dots to draw our parabola through. Once we have one dot, we actually have two dots using our axis of symmetry. If our graph is in standard form, your axis of symmetry will be the vertical line that is x equals whatever the x value of your vertex is. Okay, now we don't necessarily have to remember that, but we're always going to draw it in for ourselves just to help us visualize the mirror image thing going on with that axis of symmetry. Okay, so how do we graph from standard form? Graphing from standard form, the first thing we're going to do is just kind of give ourselves an idea of if our parabola is going to open up or open down. And again, that comes from A. So this little number right here, which in this case is -1, if A is less than 0, our parabola is going to open down, or we should have a picture at the end that looks something like this. Then we move to our vertex. From standard form, your vertex should be easy to identify. It is just going to be picking out numbers from our equation. Remember, H is always opposite of the sign we see in our equation. So if I see a -1, our H is actually 1. K will be the same sign as what we see in the equation, so it'd be a +4. We will graph that in our picture. Over 1, up 4. And then I'm always going to draw my axis of symmetry through that. So I know that my graph will be the identical on right and left of that axis of symmetry. And like once I have one dot on there, I have two dots on there. Find the x-intercepts. To find our x-intercepts, we're going to set our equation equal to 0. Okay. On this one, this is why we did our warm-up, is that you can then write it twice in FOIL, distribute, combine like terms, thank you, and solve for x. That's what we're doing. We set it equal to 0 and we solve for x. So if I write this twice in FOIL, I'd get x squared minus 2x plus 1, distribute that negative, yes. You can take him too. Just kidding. Anyone else? I know. Almost made it the whole day. I mean, 2 hours. It's okay. Okay. Again, just like our warm-up, on this one, I've got that negative x in there. Combine your like terms, but if you've got that negative x in there, we probably want to either divide everything by a negative or move it to the other side to make it easier to factor. So if I go through, another way of doing this is just divide everything by a -1. Both sides, well, 0 divided by -1 is 0. But it's going to change the sign on everything. Okay, I'm going to slide up here and keep going. I can factor this. Factors of -3 that add up to -2 would be -3 and 1, which means x equals 3 and x equals -1. Put those dots on the x-axis. So I'm going to put a dot at 3, and I'm going to put a dot at -1. Now oh, that's not 3. Try that again. Because what I want to show you is it starts to show you your symmetry. Notice the distance that this dot is away from my axis of symmetry, 1, 2 away, that I've got the exact same dot, 1, 2 away on the other side. That's going to happen with every dot we get. So that will, again, help you speed up your process and know that you counted right, because obviously I did not count right the first time, and they would have not been the same distance away from our axis of symmetry. They should always be the same distance away from our axis of symmetry. Our y-intercept is just plugging 0 into our function. So if I plug 0 into this function, I get -0 plus, minus 1 squared plus 4. Well, 0 minus 1 is -1. Squared is 1. -1 plus 4 is 3. So that dot on the y-axis, when I plug in 0, we'll put that dot on our y-axis. This one I actually can reflect. So if I am 1 away, go ahead 1 away on the other side and reflect that dot. 5 dots is plenty to draw your parabola through, okay? So if we find all of these additional points as needed, let's say like these ended up being like a duplicate answer or something, like if it goes through the origin, that's both an x and a y-intercept, so it would have only provided 1 dot there. Sometimes we just don't have enough, or if our vertex happened to be on the x-axis. But if we have 5 dots, we really don't need any additional points, so there's nothing I would do here. I would just now connect my dots with a nice smooth curve and arrows to indicate that it would continue going down forever. Questions on graphing from standard form? Okay, we're going to try that one more time here. Graphing from standard form. Okay, let's start with, does this parabola open up or down? Up, right? It's a positive number out front. It's going to open up. Use a different color so this stands out a little bit here. So at the end, I should expect my parabola to look something like that. Identify, remember, H is going to be the opposite. K is going to be the same signs as we see in our equation, so it should be a -2, comma, -1. Go graph that and then also draw in your axis of symmetry. -2, -1 is here, and my axis of symmetry runs right through that. So that line will split my parabola exactly in half. And then the work part of it, finding our x-intercepts. Go ahead and set this equal to 0 and solve. Guys, I'm going to show you on this particular example. A second option. Now, you need to be somebody that is good at algebra to do this option. and detail-oriented, because this one has a lot more room for mistakes than just writing it twice and foiling, combining my like terms, and factoring, okay? But you can start by getting rid of all outside numbers. So I could start by adding 1 to both sides here. If I had a number that was an A, I would then divide by that number. I don't. But then I can square root, and this is where my detail-oriented people, if you've seen a lot of times on your test the plus or minus symbol written in there, this is probably not the method for you. But this really is plus or minus 1, square root of 1 is 1, equals x plus 2. And so what we have is 1 equals x plus 2 and negative 1 equals x plus 2. Okay, so solving those, if I subtract 2, I get x equals negative 1. And x equals negative 3. That's a second way of solving this, is get rid of all of your outside things, square root, and solve for x if you don't want to do the whole foiling and factoring method. Same result. So again, I would have dots here at negative 3 and negative 1. Notice they are the same distance away, and if they are not, something went wrong. Go to finding your y-intercepts, plug in 0. 0 plus 2 is 2, squared is 4, minus 1 is 3. Again, I'm going to reflect that, so I am 1, 2 away, go 1, 2 away on the other side and put its reflected dot. I don't need additional points again. We won't very often need additional points. What does it mean by additional points? Maybe I didn't get this dot or something. You can plug in any x value to get an ordered pair. Now this is not, I'm just going to give you a sample here. This is not actually going to show up on my graph because it's going to go way off my graph here. But I could just evaluate for f of 1, which would give us 1 plus 2 squared minus 1. 3 squared is 9, minus 1 is 8, which would give me the dot 1 comma 8. So if I needed additional points, I just plug in an x value and it'll give me an ordered pair. And then again, it's always 2 dots because it'll reflect over my axis of symmetry. That's not going to fit on my graph here, but that's just a sample. If I needed an additional point because I did not have enough to see my parabola, what I can do. Any questions on the graphing from standard form? Graphing from standard form is nice. It's a lot more straightforward because it's super easy to see where the vertex is. Moving on to our general form, the ax squared plus bx plus c form, we have to do a little bit more work to find things like our vertex. Okay. Now, deciding if the parabola opens up or opens down is still from this number. That's still a, is the very first thing you see in the equation. And so a in our problem is still negative 1. And if it's less than 0, just like we saw before, less than 0 means our parabola is going to open down. Oops, that was not the button I meant to hit. A moment of panic that I was muted that whole time. Okay, continuing on. That's A, and then this number here would be B. This number here would be C. Why do I point those out? Because now we start seeing those in your vertex. The x value of your vertex comes from this formula, negative b over 2a. Now, if you're curious to why that is, it comes from the whole manipulating the equation into general form. I'm sorry, standard form from general form. Your book goes through a whole thing. That is not something you need to know, but we're going to start with that. So negative b over 2a, negative, fill in for b, 4, 2 times negative 1, and clean that up, okay? Well, that would be a negative 4 divided by a negative 2. Negative 4 divided by a negative 2 is positive 2. Comma, and then we're going to plug this number into the function. So what you're going to see is then me plugging that number into the function. Okay, we'll clean that up. Take this moment, if you have not done so already, to get out your calculators, because for the rest of the day, we're going to want calculators. Okay, well, 2 squared is 4. Put the negative on it is negative 4. Plus 8 would be 4. Plus 1 would be 5. Double check my mental math. It's always a little suspect. Okay, and we would put that dot here, 2 comma 5. And just like we were doing before, we put in that axis of symmetry. Now, going on from here, absolutely everything else is the same. We factor and solve for x. Sometimes that gets ugly, as you're going to see. We plug in 0 to find our y-intercept. Put in x values for additional points as needed. The only difference between standard form and general form is finding your vertex right here, negative b over 2a. Okay, so set our equation equal to 0. Yes, I would probably divide this by negative 1 to look if it's going to factor, but looking down the road, are there factors of 1 that are going to add up to 4? No. So you actually could just leave it like this and go to your quadratic formula.
Freshmen, if you haven't had your picture made yet, last name begins with A through S as in Sam. Freshmen who haven't had their picture made yet, please go to the link again.
Okay. This one does turn out ugly, I do believe. If you guys will grab your calculators, please, and get that typed in for me. Now, we have done some where we simplify that, but when we're graphing, in my head, it doesn't mean anything. Like square root of 5 doesn't mean anything to me. And so when we're graphing, we're actually going to type this in our calculator and get a decimal for this. And as soon as I have a table that agrees on that, can I get that from you? Because I'm not typing this in my calculator, and it's going to be something not pretty. If you don't know how to type quadratic formula into your calculator, to work time is going to need to, we need to get that figured out, because it's not going away. We're definitely going to have some quadratic formula going on here. Do I have an answer from someone yet? 4.47. And then we should have another one. Type in with the minus. No? Do I have a table that somebody agree with 4.47? No? I'm seeing some furrowed brows here. Oh, the square root of 20? Oh. Keep going. No. The whole thing. I want exactly where that's going to cross through. Negative 6.23. I feel like that's kind of big. Did you divide by 2? Negative 0.23? I feel like I'm remembering that number. 4.24. Yeah, I'm remembering those numbers. Let's make sure we can get that on our calculator. It sounds like we're having a little bit of trouble with our quadratic formula on our calculators here. That should be our dots. Negative. So now this becomes approximate because I can't graph exactly that. But 1, 2, 3, 4.24. So a little bit bigger than 4 on my graph there. Now, one of the nice things about our general form here is that it's easy to plug in 0. Okay. Your next step of your y-intercepts becomes very straightforward. When I'm plugging 0 into this, I get negative 0 squared, which is 0, plus 4 times 0, which is 0, plus 1 is 1. And again, that's a nice dot for me to reflect. It is 1, 2 away from my axis of symmetry, so go 1, 2 on the other side and put my dot there. Okay, and again, 5 dots is going to be enough to draw our parabola. We know where our vertex is. We know where it's hitting my axis. I can draw in my picture. If, again, at this point you're realizing that you do not know how to correctly get quadratic formula typed into your calculator, work time, you need to get that figured out. Okay, so I'm going to let you work a little bit ahead of me on this. While you're working a little bit ahead of me, I can help some of you that were having trouble with that quadratic formula if you want me to just look at what was in your calculator. Get this one graphed. You need to have your numerator grouped with, here, let me show you. You need to have that whole top part grouped together. So I'm going to, yeah, because otherwise it's only dividing the square root of 20 and not the whole top part, and I bet that'll give you the correct answer. Yep. Okay, because we do still have quite a bit to talk about today as far as then how do we use these in more of a real world situation, I'm going to go ahead and jump in with you right now. I see that it is a 3x squared. 3x squared tells me A is positive. I should expect my parabola to open up. The positive tells me it's opening up. To find the vertex, I start with negative b over 2a. Negative b over 2a. Negative, and b is also negative, over 2 times 3. So a negative negative is positive. The denominator is 6. So it would be 2 over 6, or 1/3. This is, again, why I told you you're definitely going to want your calculators today. Because now I'm plugging 1/3 into the function, which I don't want to have to do by hand. Again, make sure you know how to use your calculator. Yep, negative 1 and 1/3, 1.3 repeating, okay. Graphing this again becomes approximate because I'm graphing a 1/3. The way the graph is numbered, I can't go exactly to that number, so 1/3, negative 1 and 1/3 would be approximately here, down 1 and 1/3. My vertex is going to be somewhere approximately there. Which then again, I'm always going to think, okay, then my axis of symmetry runs through that, and what's on the right and left of that line should match identically. Again, no difference here is that we set our equation equal to 0. Okay. This one actually is factorable. Use whatever method you learned in Algebra 2 that you hopefully got really good at. If you are a slide and divider, please don't forget your and divide. And if you don't know what that means, either don't use that method or you're probably not a slide and divider. I'm a guess and checker. I can go through any method that you have, but I will tell you right now, the number one mistake I see is with my slide and dividers. So I would not encourage that method. So how do I do this? If I'm a guess and checker, my first number, when I take this number times this number, I have to get 3. Well, there's only one option, 3 times 1, right? That's the only way I can get 3x squared. My last number times my last number has to give me 1. Well, 1 only has one set of factors, right? 1 times 1. So it has to be a 1 times a 1, and then we just have to then play around with the signs. When I multiply this together, I need a negative 2x squared. And so my options are 3x and 1x. To get a negative 2, I need the 3x to be the negative and the 1x to be the positive. So that's going to give me a negative 3x, a positive 1x, total of negative 2x. It is factorable. Now, if I did not realize it's factorable and I went to my quadratic formula, is that okay? Absolutely. It will give you the correct answers at the end. Set anything that has an x, which is all of this, equal to 0. And solve. We get negative 1/3 and we get positive 1. Negative 1/3, positive 1. They should look equally spaced on either side of our line, and they do. Find my y-intercept, plug in 0. Zero minus 1 is negative 1. Again, I could reflect that. Equally spaced on either side of my axis of symmetry. Again, 5 points is enough. Go ahead and draw through our dots for your parabola. Brady?
For slide divide, we just add 3 over
Yeah, so by slide and dividers, you take that first term, and I don't love it because people make mistakes, but I will. It is something that you multiply. 3 times negative 1 is negative 3. Factors of negative 3 that add up to negative 2 would be negative 3 and 1. But then you have to go back and divide by that number, and people forget the divide part, and how to clean that up is why I don't love this method. I've written on a lot of pre-calc tests over the years, and divide, because we forget to go back and to divide, okay? But that's your x minus 1 right there, and there's your 3x plus 1 right there, okay? All right. And if you need a method to factor, because again, factoring is not going away, come talk to me. We have now looked at this multiple times, but I haven't referred to them like as a maximum or a minimum, but in the real world, a lot of times that's what we care about. A maximum value of a function or a minimum value of a function, and what kind of functions do those come from? Well, if our a value is positive, we said that it opens up, right? And if it opens up, that means your function has a minimum value. And if the a value is negative, or we had earlier said that it opens down, that means that that function has a maximum value, and it is whatever your vertex was, right? That dot that we put for our vertex becomes then your maximum value or your minimum value. So as we look closer at that, depending on what format our function is in, if we find our vertex, we have also found where the maximum happens is your x value. What the maximum is your y value in your vertex. And that can come from your negative b over 2a, or if it happened to have been in standard form, that h comma k is the same numbers. Okay, so you just need to understand that when we identify the vertex, whichever method we use to identify the vertex, where the maximum happens is x. What the maximum value is always your y. And knowing those two different things, understanding what you just looked at in your vertex ordered pair is something we're going to ask you a lot. So let's look at an example where that would be a question. Given a function here, f of x equals 4x squared minus 16x plus 1,000. It says determine without graphing whether this has a minimum or a maximum value. So what's going to tell us if it has a minimum or a maximum? The a, right? Look at a. Look at a. Our a is 4. That is bigger than 0, right? Which means it opens up. So then think about that little picture. If it opens up, now answer the question. Do we have a maximum or a minimum? Minimum, right? Okay. Find the maximum or minimum value and determine where it occurs. Where it occurs is going to be your x value. The maximum or minimum value itself is the y value in your ordered pair of your vertex. Now ours is given to us in general form here, which means we're going to have to go through that whole negative b over 2a thing. Okay, well, negative b over 2a would be negative 16 over 2 times a, which is 4. Negative negative is positive. 2 times 4 is 8. 16 divided by 2, 16 divided by 8 is 2. Did I talk through that too quick? We're all good with that? So we're doing nothing different than what I was doing earlier to find my vertex. Negative b over 2a, go ahead and plug that back in. Grab your calculator. Somebody type this in for me real quick here. Plug in a 2. I think it's a pretty big number because we're adding 1,000 to it. I want to say it was 900 something. 984. Okay, so again, we know our graph looks something like this. We know its minimum value is happening somewhere here, right? So the minimum value is 984. Where it happens? At x equals 2. Answering those two different questions. Okay, so identify the function's domain and range. Let's talk domain. Is this a fraction? No. Radical? No. Radical on the bottom of my fraction? No. So what's its domain? Negative infinity to infinity. Don't forget old things we've already talked about. There's nothing special about the domain here. It's not a fraction, it's not a radical, it's not a radical on the bottom of a fraction. But the range we do need to think about a little bit. We know that it's a parabola that opens up like this. We know that this minimum value happened up at 984. Does that help you with your range now that I draw a little picture of it a little bit? Lowest point, minimum, right, 984. Does it actually hit at that point? Yes, so brackets. Goes up to infinity. So maybe draw yourself a little visualization of what's going on here to help you with the range part of these parabolas. Any questions? All right, I think we got one more to go through. So again, kind of an ugly one to start with here. It says an archer's arrow follows a parabolic path. The height of the arrow, f of x in feet, can be modeled by f of x equals negative 0.005 x squared plus 2x plus 5. And x is the arrow's horizontal distance in feet. What is the maximum height of the arrow and how far from its release does this occur? So again, when they're asking us the maximum height and where, we look at our vertex. Where is our x value? Maximum or minimum is our y value, right? So that's where we start this one, is just find your vertex. Negative b over 2a, plug that back in to find the y value. While you're doing that, I will point out that our a is negative. So again, kind of visualizing what's going on. We've got this arrow shooting up into the air and coming back down is making this upside down parabola. So we would start with our negative b over 2a, which would be negative 2 over 2 times negative 0.005. Again, that's a calculator problem. What do we got for that? 200. So in my vertex, that's our x value, right? Plug it in to find our y value. And somebody let me know when they got that typed in. It's 205. Okay. So one of the important things that you understand is that in every vertex, this is where And this is your max, or in our case, yeah, our max or min value. Okay, so answering those two questions, it says find the maximum height. Max height is 205 feet. And it was at 200 feet from release. Okay, find the horizontal distance the arrow travels before it hits the ground, round to the nearest foot. If we think about what's happening here, our arrow is being shot up into the air, and actually knowing what I know about this graph, which we'll talk about on the next part, it's shot up in the air like this. So here is where it hits the ground. Here is where it would have started ground level, okay? And what those are your x-intercepts. Or set your equation equal to 0, right? So when it's asking things like where does it hit the ground, things like that, set your equation equal to 0, just like we were finding our x-intercepts when we were learning how to graph these. So if I set my equation equal to 0, I absolutely would put this into my quadratic formula, because I'm not going to try to factor something that has a negative 0.005 in front of our x squared, right? So I would go grab my quadratic formula. Okay, and for the sake of time, I think I already typed this in my calculator. It does come out ugly. Maybe I typed this in my calculator. There it is. You get two answers, negative 2.49 and 402.49, I think. So what are those two things? This one would have been back here. The 402.49 would have been here. It said round to the nearest foot. So I'd round that to 402. So I'd say at 402 feet is where it comes back down and hits the ground. So why did this one start at negative? Well, what happens is when you look at where we actually shot it, it starts shooting 5 feet above the ground. If I look at time equals 0, or at distance equals 0, I should say. We get 5. So it started up at 5 and then shot into the air. So graphing the function that models that path, we would put all those important things on there. It starts up 5 feet above the ground. It shoots into the air, and it comes back down. We now know that that happens at 402, that the maximum height it hit was 205. Oops, I'm going to put that over here. 205 feet, and that happened 200 feet away from where I shot the arrow. So kind of marking all of that important information. When you are asked to mark that important information, that's exactly what we would do, is mark, let's see if I can get that out of there. No, I cannot. Okay, never mind. Mark your height and your vertex, mark where it hit the ground, mark where your y-intercept, all of that. Your assignment is, on my math lab number 26.